Okay, so now we want to plot the value of certain points at any given time, or in fact over time. So what I'm going to do is, on the left here you can see in my pipeline browser, I've got this thing called mycase.openFOAM, so that's basically the entire simulation. I've got this thing called slice1, which is just my slice down the middle. And you can see the eye is on in this one and it is grayed out in this one. So I'm going to gray out this one and turn this one on. So now I'm looking at the whole simulation domain. The whole simulation domain. I need to place a probe somewhere in my domain. Okay, so the way I do that is I come up to this toolbox here and this probe location button. And I press that. In fact, I'm going to rename my probe location to be vent because I'm going to put this one right by the vent. And if I come down to my property editor, I have the option of defining the center of my probe. Okay, so I'm going to place this in terms of X, Y, and Z. I'm going to place this 1 meter above the vent with radius 0. Okay, so nothing tricky here. I just have to press apply. And you can see here that, I might just close this color map. I get this thing called the spreadsheet view. So at this probe, which I'm calling vent, I have a mass fraction of just under 5%. I have a temperature of 1200. This is at time 100. Maybe I should go back to the start. Time 0, yeah, so just under 5%, just under 1200 degrees Kelvin. Now the velocity of my my fluid mixture is 125 meters per second. My mass fraction of air is 0.75%, and then my coarse and my fine particles, this is the mass fraction of those, and the pressure. So I have this information at this probe location at any given time. I can scroll through here and you see these values changing as we go through the time steps. Okay, I'll just go back to 0. But what I want to do actually is plot this over time. So what I want to do is I take this vent here, I'm going to click on it, and this button here, plot selection over time. I'm going to click that. Okay, so what I need to do then is this button here only reports selection statistics. I'm going to uncheck that, and I'm going to come over here to the spreadsheet view and click everything here so that I select it, come back to my plot selection over time, and press copy active selection. Okay, and so now I should be able to apply that, and it should plot everything in a mess. Let's see what it does. Hopefully it doesn't crash. Okay, good. So see, now we have a chart over here which actually is plotting everything on the same graph, which is not ideal. It's plotting the coarse mass fraction, air, fine mass fraction, the pressure, temperature, water mass fraction, the velocity magnitude, and something called the point coordinates. So it has successfully plotted everything, but on the same graph, which is really hard to visualize or understand. So I come back to my property editor here. Now that I've plotted everything once, I can select what I actually want to plot. So I might just focus on the coarse particles here. So you can see that 1 meter above the vent, we very rapidly reach a value for the coarse mass fraction of roughly 0.2376. And well, the value over time oscillates around that number. So you can see the final time here being 3,600. So, well, just above the vent, this is not that interesting, right? Because you might expect if this is how much coarse particles are being ejected from the vent, it may not change very much. So instead of plotting at the vent, let's create a new probe now. So I'm going to create a new probe. I'm going to call this one ground 100 meters. And I'm going to define this probe to be placed at 100 meters along the X direction, 0 along the Y, and 0 in the Z. So it's on the ground, 0 at the Z. And apply that. Okay, and so I might close my spreadsheet view for the vent now. Maybe I'll close that chart as well for now. And again, you can see that at time 0, I have the value of these parameters here. So in fact, my vent is more than 100 meters in diameter, I just remembered, so maybe we should say ground 500 meters. So we'll change that position of that vent to 500 meters. If I apply that now, I can see, okay, well, at time 0, I have no coarse particles here. So mass fraction, of course, is 0. Everything, in fact, at this location, 500 meters from the vent, is air. So now I want to plot how that changes over time. So again, I'm going to select ground 500 meters, click plot selection over time, only report selection stats, turn that off, highlight this data, back to here, copy active selection, and apply. Lots of buttons to click. So as this is plotting, it shouldn't take too long to plot. And then we can, yeah, there we go. Okay, so now again, I'm going to come back to the properties toolbar and only select the thing that I want to look at, which actually is just the coarse particles. So this is basically going to be looking at the settling of the coarse particles over time at a position 500 meters from the vent. And so you can see here that the coarse particle mass fraction is changing over time here. It's increasing from its initial value of 0, but it's fluctuating here. So, well, this is interesting because probably what's going on here is that we're also getting some fine particles deposited. So let's have a look also at fine particles. And so we are actually getting some fluctuation in the fine particles here too. So, well, maybe let's also look at air and also H2O. Where's H2O? H2O down there. So actually, there's not much water vapor at this point. There's the green line there. If I just turn off air for a moment, we're mostly actually getting air and these particles classes here. So what we could do is we could integrate these functions over time to find out the actual mass at this point over time. Okay. So this is how we visualize the evolution of some data at a point over time, and perhaps in the next video we'll look at the evolution. Well, we'll plot along a line, I think, over time. We'll plot some parameter over a line, maybe up the vent, and see how that up the center of the plume, and see what that looks like.